Yeah,
Yeah.
yeah. Just no. Since you have started recording, I just wanted to mention again that it is not just not a formal thing.
Okay.
Uh, okay, go ahead. Mm.
Yeah, so don't worry. I'm not taking this as a formal.
Yeah,
This is only for my, support of growth. For that reason, we had to.
yeah. Go ahead. Yeah.
One second. Let me open my presentation. So this part of okay, I share. Can you see now?
It is coming up. Yeah, it is.
See, I prepared this last week. After you said, somewhere on our conversation that you, after seeing the safety video, something towards welding will be preferable.
Yeah, we are not in the safety side. We said, I told you about, yeah, we are doing something to do with the weld with the AI system.
Okay. Anyhow, based
Yeah.
on that kind of input, I started doing this, and to some extent, we have grown up.
Mm.
So I thought I'll first have a small vetting with you before we make it into a full form of a product.
Yeah.
So this welding defects identification is it's a universal kind of a requirement. Many organizations which is into core engineering, yeah, they what they do is they the joining points, either welding or casting or fabrication or fastening or whatever it is, brazing, soldering or whatever it is, they all have the metal joining process, which is a permanent fixture of welding being of a greater importance. So I told my team, welding defects identification is very important. And we took up a dream, like, it should not be like any other kind of inspection that is happening in an industry. It should be novel. It should be
Mm.
novel and it should be useful to the people who are performing as welders. That's where I was, suggesting my team so that we go ahead with a system that can be useful for the welder per se. If he knows that his weld is good, then his satisfaction will lead to better, performance in his job, and that will help all other people working in the environment to also contribute towards a good work. So that was the big vision with which we started this project. See, when we said welding defect identification, we wanted to have AI into it. Artificial intelligence requirement for welding is because every workman will always say that his work is good. It is subjective. But when it comes to the work, it needs to be objective. And so we wanted to have a third party kind of an inspection. That is where artificial intelligence is being involved into this identifying of welding defects so that the person who is doing and the person who is being benefited out of the product are both satisfied that the product has come out in a nice way. So we are enhancing the quality or the welding defect identification to improve the quality of welding. That is the preamble on which we started working on this. As we were working on this, this computer always requires a kind of a guidance. See, it should know, as we are into computer vision and deep learning, our company, WRWS, we are into computer vision and deep learning. This is our expertise. And in this, now we are implementing a lot of projects on Industry 4.0 across, I should say, across the globe. The reason is we are bringing cyber physical systems in place. It means any physical system, any physical machine, process, or a kind of a product that is being operated with internet is being able to make a cyber physical connectivity so that it can be worked on from any part of the world. Virtually, we can connect this machine and make it work whenever the person who is owning it or working on it can perform on it by from anywhere using internet. So when we are having this kind of a facility, we need to also identify what are the defects that goes on into the system. So this part of welding defects, what we have classified as one is called bad welding. It means it is not performing to the parameters within which the metal joining happens, or good welding because that is the one which we need to have. Then excess reinforcement. When young people who are naive to this kind of a working, they may have their torch placed in one part of the metal so that it melts more, and whereas the other part of the metal it doesn't have, or it goes on melting on both the sides so that the excess reinforcement happens. Then the porosity, as we create this welding, now any kind of porous nature in the joint is bad to welding. And then spatters, wherever the metal spatters or the filler material splatters over the metal, we have to again rework in removing those spatters. So based on these five, there are more effects.
Where do you include the penetration of the weld?
Where do I?
Penetration of the weld, okay, when you do the weld, some amount of metal will
Correct.
burn and it will go. How much deep that weld will go?
Okay.
So that
See
is
that
another.
those things are dependent on the data we create, capture.
Okay.
We can take penetration of weld or limitations on penetration of weld. If there is any kind of a pictures, we can take it. See, we are computer programmers. So we
Okay.
give the
Yeah.
computer, these are the parameters on which it has to see.
Yeah. So visible thing you can do here, not penetration we cannot see. Okay.
Yeah, we
Good.
cannot see. Maybe it could have been identified in a X-ray, destructive testing kind methods, X-ray technique or any kind of a technique, where if you can specify it and say this is good and that is bad based on penetration, then we will take those pictures also.
Okay.
So like that we can go. So these are the classifications we have taken, and we are open for taking more classification of defects as you people tell. Okay. Now coming on to the algorithm. How do we create this kind of an algorithm is we have prepared a data set with pixel-wise labels. This is good, this is bad, this is excessive penetration, this has porosity, this has splatters and all the stuff. These things, we have created the data set and we have collected from, there's a lot available in Kaggle. And so, this is a continuous research across the world. So the data sets are available and we have picked, and we also created our own data sets from the local market, from wherever the small kind of a welding repairs are happening in automobile shops, etc. And I've also asked Godrej to give us pictures. They are willing to give us pictures. So I will be taking a lot of pictures from Godrej because Godrej is one of our prime customers. Next is selected an instance segmentation for the model. And then we have used this segmentation method so that we can define, collectively identify where the defects are. So this kind of sigma instance we need to create, and then create the model and train the model based on the data set what we have, and then build an algorithm based on each of the pixels into which the detection of the classes go and hide. So this is how we have done. So this is completely a computer vision and deep learning technique. So for deep learning, we have taken the vision part, and then we have started making the algorithm. See, in this detection part, what we are doing is we are having identification of color coding. If it is a bad welding, we will show in this algorithm blue color. And if it is a good welding, we will show it in green color. If it is of excess in reinforcement, white color. Crack, if it is there, yellow. Porosity, black. Splatters, purple. Like this, we identify so that we can easily capture, and the computer is in a position to differentiate the colors and then pick it up and show. See,
Mhm.
wherever these pictures are being reinforced for a decision making, there is an accuracy that is required. We have taken an accuracy of 0.5 and above, 50% and above. If there is a mild require, I mean, coming like 30, 25 and all, we want to exclude it because our capture should be on a better run. So we have taken more than 50% accuracy and then we have boxed it and then we have identified for decision making.
Yeah, in a vision system, how do you see the porosity, which is visible on the top layer, or how
No,
do you see?
visible in the top layer only, but it is matched with the pictures.
Hmm.
Thousands of pictures of porosity is matched
Hmm.
so that the pattern recognition happens.
Okay.
So from through the pattern only we find out. See, we as engineers, we don't put our brain into it. We only make the reference of good and bad. That is good, G and G. Within
Hmm.
this, it has to identify. There is nothing in between. So if
Hmm.
there is anything in between, we go for the SAE, subject area experts, to clarify us, and then we clarify, get it clarified and put it either in G or NG, and then we make the decision making through the computer.
Okay.
See, for this system, when we are doing and when we are implementing, what happens is there is something what we can do and what we cannot do. So we have to be very clear with what we are doing and what the partner who's coordinating with us or a customer who's willing to take our services to do. We can do one thing. We supply the algorithm along with the system, where a GPU. GPU is a graphical programming unit. See
Hmm.
here, like a CPU which goes with the text form, or even if you can update it with a voice form, whereas GPU goes with all the imaging form. So the image processing should be faster, and so a system with GPU will be trained by us, and we'll give it to you. The cameras to cover the area to be scanned. Also, we will suggest you can buy it so that whatever camera you have it in your place, which can be a mobile camera. It need not be fixed in one place, so that the person who is working, he can scan the area wherever he has weld, and he can see from the display what the computer vision and deep learning is telling him whether this is right or wrong. Then the integration part, both the camera and systems that we will do. Install the software, nothing but the we give the part of some algorithm to you so that you can have the user rights and training. We train your people, and then the output based on what you want to see or what you want to alert or any kind of application programming interface you want, we'll give you. So based on the software developed, we customize, we give you a software for installation, and then we service and maintain, and we do the upgrades. Whereas as partners, we want you to have the systems with GPU, cameras to cover the area to be scanned. If it is in India, we can buy and give you a system with GPU. If you are abroad, then it's better you buy and keep it, where we will take it on remote and we can set it right. Then the installation and software rights and things, all these parts, we can do it for you.
Yeah, actually, this is exactly the same thing which another vendor is providing us. Problem is, we are also doing the same thing. You give the software, and then another partner has to put everything together.
Hmm.
So there is actually what my understanding from my boss is, they single
So you
one
want everything to be done by us?
managed managed by one person.
No, it is possible. Thing is, see, people have to come to the site. People have to be in the site to set it right. That's all.
Yeah.
See, other things, cameras you will have, you can buy and give. System also you can buy and give. We will come there, integrate it. We can install the user software. We can train your people, and we can show you where the alert is. It can be as a display or a beep or a color light or whatever it is. Those kind of things we can set it right in the in the system, so that the user of the defect detection is able to do it. We can do it. It's not a problem. It's only our engineers have to travel to the site to do it. If your people are there, we can straight away coordinate and get it completed. Nothing else. That's let us see.
Yeah.
That's when it comes
Yeah,
to
that
we
is
have to implement it.
that is not now. I'm just giving my feedback. That
No issues. No issues.
No, most of the customers, they don't want to deal with the two different people. They want one person. Yeah,
Yeah, we can do it. We can bring and come and we can put it. We can even give and get you the camera. We can see. I'll tell you on a bigger note. Along with camera, we can also have a mobile application also ready, so that people above the welder, see, for example, if there is a supervisor or an engineer in the workplace, we can install the app in the camera of the mobile, and we can give them to also even cross check, so that it is easy for them to have a control over the work. So these are all upgrades on which we work. So we can think about it as we come to it later. Okay.
yeah.
Going further, see, this is how good welding, the picture shows. Bad welding, again, how much of accuracy, it's around 0.92 it takes. Bad welding,
What
again,
is that? What is that number means? That 0.7, 0.9, that represents what actually?
that is the amount of matching we have with our
Oh,
existing
my.
defects.
Assuming your template is 100% one. This is
Uh,
0.7.
yes,
Okay.
yes, correct, correct. So
Okay.
how much it matches,
Mm.
that is the accuracy.
Okay.
Okay. Yeah, the more the pictures, the value goes up.
Yeah.
The more the alignment. See, bad welding, it can show. So it is like this. And then see, spatters. Sometimes the spatters is around 0.26. It means that kind of a spatter is not available in our system. It has only few matching. See, and it
The
comes to.
other spatter it is not recognizing. I see a lot of other spatters which
Yes,
is
yes,
not.
yes, yes, yes. Some of them are not recognized because that kind of a pictures are not available. See,
Mm.
many things. Spatters is just a throwaway of a metal
Yeah,
during welding part, which
right.
can be even rust or any other thing which can happen. Even after this, we have to wipe it clean or grind it, or many kind of a thing that has to be done after welding.
Yeah, that's okay.
Okay.
Yeah. Just
So
ask.
excess reinforcement, we have about 0.68. Good weld, this part is about 0.74. Bad welding is around 0.2, like this. So it all depends on how much of a pictures we are going to add on, so that the computer become more efficient and more right. In addition to this, what is there, this gives a eye opening for the person who's working on it to correct himself, instead of blaming him that he is wrong. So self-correction happens when we have this kind of a system. So, and they when they go out after they work, they can take pictures of their work and they can flash it to the bosses, and then say, boss, I've done my work. You see, so much of a percentage, reliability I'm getting onto my work. So that way, this adds value. It adds value to the customer. It adds value to the product, to the performance of the person who's working, adds value to the organization, reliability to the product, and many things. So like this, a lot of good things are happening. So now coming on to how this is being captured and checked. You
Yeah, that
see,
I was.
this is the video which I have already shared. See, um, uh, this is how, when you point your camera onto the welder, it will show you what it is. It is a bad weld, and then you can run your camera down, and you can see good weld also is there. And then as you proceed further, you also see some other bad weld is there. No, like this, yeah, progressively you can have just a camera pointing out on the work and then identifying which is right, wrong. You can also see porosity, cracks. Many things are shown in this video. So that way, it will help the person who is working. See here, some non-filling is also there, and it is excess reinforcement is there. So these things can be captured, and we have to train the system with more pictures. The more pictures we have, the more better results we can get. And for this, what we will do is we will train the employees in your company. If you have some kind of people in with computer science background or people in quality, you will train them how to add more pictures so that this system becomes robust, and it takes care of all kind of future defects also that can be added into the vision system for identification. That way, this total algorithm is made. This is how we have done it, and this is the video. So this is what I wanted to share with you, Kuru.
So actually, normally in our case, there will be only one or two cameras. There will be some 50 weld. How
Ah,
do we don't actually, the assembly happens. This is a continuous process. You'll have only less few seconds, to look at.
yes.
How do the system look at all the weld, and then say
No, you
which
have
are
to just move
weld.
the camera across all the welding zones. That's it.
Yeah, so one camera can look at
Yeah,
every.
one camera is enough for one product completely.
Yeah, so it will look at all the world, and then it will
Yeah.
take.
See, I tell you, even other than this, I don't know whether I have that system in my, what we are doing for Panasonic. We
Mm,
are using a Kobo to hold on to a camera. And a Kobo will rotate its arm across the package and
mm.
identify and read, QR code, barcode, MRP, packaging, model number, everything. Like that, we can have it. But, for this one, I don't suggest you need to have a kind of a Kobo. You can give it to the person who is welding, so that he can move his camera around and he can see what is happening, and everything can be captured.
Yeah, our cases, the individual is not welding. Normally, most of the cases, robot is welding robots is welding, and we don't even see that. It will weld and it will bring it back and put it back in the
Yeah.
conveyor. That it will move to the next station, and then there people will inspect. So
Hmm.
that inspection only we wanted some system to look at, and then say these out of this 15
We can
weld or
have it fitted on, then the camera can be fitted on the Robo or Kobo itself.
the weld spatter will damage the camera. So
Or then after the welding process,
yeah,
we can have to, move this part.
Mhm.
Because the camera,
Not
camera is
finding
like an
trying to
eye.
find a solution for that. I'm trying to see how it is applicable. Um, so this was a good start. Actually, it's
Mm.
good. Yeah, yeah.
What we will do is we'll first use it with hand, then later on see with the automation part of how to swing it. We can
Yeah,
have,
actually, the assembly line, how it works, no, actually, people cannot uh, uh, use a handheld camera and go and look at all the weld, and then that may not be, that will be a lot of time consuming, So in the continuous production line, that may not work.
then we can have a Kobo fitted with this camera, and we can place it after the welding station. After the weld is done, the Kobo can be navigated for the way how it should go for inspecting.
Yeah.
And then it will give you a report, and then based on the thing, we can identify wherever if there is any alert of bad defects, then it will alert you, and then the person has to take it for a repair or rejection or anything. Whereas
Mhm.
all the good ones will go for assembly.
Yeah.
So that
Really,
way,
the output what we require is, it's a good weld or bad weld. I know there are several things to look at.
mm,
So system will say, yeah, everything is good, everything is bad, or um, not, 2 or 3 parameters are good, out of 5 parameters. That is not required for the production line.
correct,
Maybe
correct.
that
You want
should
either a good one or a bad one.
that
Correct.
should yeah, that should be recorded. The different, then they can do the weld repair or something. They
Correct.
can use.
Mm-hmm.
Yeah.
So no,
Yeah.
as we are developing, we have gone into
Yeah,
identifying some more defects.
yeah,
But,
really good. It's
uh,
very
otherwise,
yeah,
we will club everything as bad weld.
yeah,
Good weld will be separate, and all these defects will be called as
yeah.
bad.
That should be the immediate feedback to that person who is checking.
Correct.
But in the background, it has to be stored as, this weld is bad because of the porosity, or because of the weld width is not enough, or weld length is not enough. So is that your system is looking at that also? Okay, based on the template, yeah, we will can look at length of the weld also, no?
Yes, we can do it, and see the color coding. If
Yeah.
it is bad, it will be blue, and here, if it is green, it is good. So
Mhm.
similarly, we can create a color code like red and green. Green means everything is good. Red means bad. And
So when you say good and bad, you will add that well tolerance also into that. Suppose if the maximum length of the weld is, let us say, 25 millimeter,
hmm,
and allowable tolerance is plus or minus 2 millimeter. So
hmm,
you have both parameters built into your thing. Suppose say 25 becomes 22.
hmm.
Then is that the way it works, or how it works? How it says it
No,
is
it
good?
can be. See, based on the tolerances, but the tolerance has to be measured.
Yeah.
So that means the camera will be a different kind of a camera. It should also identify the picture, and it should also do a measurement. Like you have kind of a laser kind of a one data to one point of measure to another point of measure. It has to do. So
Mm.
for now, what we are giving is only a image capture.
Oh, okay.
Image capture. But if you want, dimensional check, then that will be opting for a different kind of a camera.
Okay.
So we can't do it here.
Okay.
Okay. So this is what I've done, Kuru.
Yeah, that's
So,
good. This
okay.
great.
So
So
you think through, and you help us in getting a meeting.
yeah. So I already talked to my boss, and she said she needs more information. Basically, she may be asking something what I asked in the same line.
Okay.
Uh, Maybe she'll be back on after 2 weeks, but after once that when they come back, they'll be busy with so many things. But she will give you a call, and you can explain these things to her.
Okay, then. Thank you.
It's a really good.
Thank
So
you.
since
Thank you.
you are in AI recently, or
Come again?
since when you have started working on
1 year.
artificial on 1 year?
Last year I got retired and then got into this completely.
Okay, so you have started a new venture. Huh?
Yes, yes, yes. So this is
Where
a
were you
new
working?
avatar,
You are working some. Where were you working?
and I'm losing your contact.
Oh, so you are working somewhere, or I thought you're in business for a long time,
No, I was in business for a long time. That is between 2000 to 2011,
Mhm.
and then I went into employment again, and
Oh, okay.
I got retired from that company in 2023. And then since 2023, I'm on again on to business.
Very good. Okay.
So this is my second innings.
Okay.
Mhm. So that's
Okay.
all.
Nice talking to you.
Thank you. Thank you very much. Thank you very much for your time. And
Yeah.
thank you for guiding us.
Yeah. Definitely,
Mm.
I'll talk to my boss, and I already talked to her a couple of times, and she said she was busy, and she's going to talk
Okay.
to you.
Nice of you. Okay.
Let us
Thanks a
see.
lot. Bye. Bye.